Hello, this is Rakesh Rao from DesignSense Software Technologies, Bangalore. In this GeoTools video, I am going to show you how you can create a slope map. A slope map is a color-coded display of 3D faces according to the slope. Now in this drawing, you can see that we have a 3D terrain, and if I zoom in, you can notice that these are all 3D faces with different elevations and have been created from a digital terrain model. Now you can create this terrain in different ways. You can either create this in GeoTools from points, or you can create it in BricsCAD Pro using the civil tools, or you can also create it in AutoCAD Civil 3D and so on. Now in GeoTools, under the civil tools, you can see that we have color coded slope display of tin faces. You can also start it from the command line by typing gt_slope display. Now when you start this command, you can see this menu. So here you have to answer a few questions and make your selections correctly. The first one is whether your tin elements are in 3D faces or 3D polylines. Now in my case, these are all 3D faces, so I'm going to choose 3D faces here. Display slope in percentage or degrees. You need to choose this correctly. So if you choose it in percentage, then you get all these options. So the percentage intervals can be specified, say for example 0 to 5, 5 to 10, 10 to 15 and so on. So you need to choose appropriately your interval, and for each interval you can also choose the color. So by default already GeoTools will assign you these colors 1, 2, 3, 4, 5, which means red, yellow, green, cyan and magenta. Similarly, if you choose degrees, then you get this option activated here. So here you can specify the slope in degrees. Now you can also notice here that you don't have to annotate all the slopes. You can just choose whichever interval you want. Like for example, if you want only two intervals to be shown, you can just choose the first two, and you can choose maybe like 0 to 11 and maybe 11 to 55 or whatever. So it's up to you to choose your intervals as you want. Also note that this option is available in the ribbon as well. So if I switch on the GeoTools ribbon, so under GeoTools, under civil tools, under surface tools, here you can see that the surface coded display of tin faces is available here. So let's go with the default, which is percentages 3D faces. Hatch control, this is another option that is important. Here you can specify whether you want to create one hatch per polygon or one hatch for the entire slope area. Please remember that creating hatches can make your drawing quite heavy, so use it on a small sample and get an understanding of the performance, and then you can do it on your full data. Layer for slope representation, so I'm going to choose slope face as my layer. Slope legend text height is 2, that's fine. So I'm going to now click on OK. Select 3D faces representing the tin model or enter to type layer names. So instead of selecting all this manually, I'm simply going to press enter, and all my 3D faces are in this layer, which is surface SSDEM. So I'm just going to select this layer. So now you can see that the processing has begun, and it is going to now color all the 3D faces based on the slope of the 3D face. Now this will take some time depending on the size of your data, so you have to be patient and wait. You can see that we are now nearing the end of our processing. So for a data of this size, it has taken about 4 to 5 minutes to do the processing. So at the end, it will ask you pick start point of slope table. So I'm going to pick this point here. So that's the slope information you can see on the screen. Now it has created the table. Do you want to scale the table? I'm going to say yes, and I'm going to enter the scale factor as 25. And you can also export this as a CSV file, so you can see that the default path is shown based on the drawing. So you can see now that the entire slope data has been color coded, so based on red, yellow, green, cyan and magenta, and the values are also shown here in the slope table. So you can see that the same data has also been exported to this file demslopes.csv, and it's available in the same folder where the drawing resides. So these slopes are created as hatches, and they sit exactly on the same position where the 3D faces are existing. These hatches are 2D objects, so you can see that your hatches are at 0 level while your 3D faces are at the exact elevation of the terrain. So only when you view it in the plan you can see it correctly, one superimposed over the other. Thank you for watching this video, and do let me know if you have any questions.